this part of our warm-up, we're asked to decide if each set could represent a quadratic function. So let's talk about the first set. What did you guys decide, yes or no? No, why not? It's linear. How'd you know? Okay, so there's a constant ratio of how your y values are increasing to your x values, okay? There's something you can look at called the first difference. So negative 11 to 5, negative 5 is plus 6. Negative 5 to 1 is plus 6. 1 to 7 is plus 6. 7 to 13 is plus 6. And my x values are going up by a constant rate as well. Plus 2, plus 2, plus 2, plus 2. So when you have this is called a constant first difference. That's how you can tell if data is linear. That's one way to tell if data is linear. Could you have also plotted this on a graph? Yeah. All right. What about B? Is that quadratic? That's not quadratic. But I'm not asking you, is it piecewise? I'm asking you, is it quadratic? That's not a quadratic function. If you kind of vision this, you could check your differences, but also kind of just think about what's happening. Negative 2, negative 10, 0, negative 2, 2, negative 6, 4, negative 2, 6, 10, right? We don't really know what's happening, but I know it's not a quadratic function because a quadratic has a single max or a single min. This has a relative max and min. Okay. What about C? Yes. How'd you know? Okay, we noticed the symmetry. Okay, we've got 1, 1, 9, 9. We would bet that negative 4 would give us 25. The vertex would have to be somewhere in between here, right? Because that's where our symmetry is. Okay. There's another way to check, and it's called second differences. So check our first differences, minus 8, 0, plus 8, and plus 16. Is that a constant first difference? No, so it's not linear. So check your second difference. Plus 8, plus 8, plus 8. Because you're going from 9 to 1, which is negative 8. Okay, this is a constant second difference, which implies that it's quadratic. Okay? All right, flip over onto the front and let's start our notes. All right, so the reason we did this, the reason we started with factoring for this unit is because we're going into quadratics, okay? And factoring is going to be a way that we're going to have to solve quadratics. So let's review the quadratic parent function. Remember that it's f of x. Sorry, the f got cut off. F of x equals x squared. Okay, so when I plug in negative 2, I get 4. When I plug in negative 1, 0, 1, and 2, 4. All right, go ahead and graph it. Should pretty much be able to plot the quadratic parent function in your sleep by now. Okay, what's the domain? Negative infinity to infinity, all real numbers. What's the range? 0 to infinity. let's practice and review graphing with transformations. Okay, so look at number 2, x minus 2 squared minus 1. How has the parent function been transformed to give us this graph? Okay, right 2, down 1. So my vertex, as we just remembered, was at 0, 0, so I go right 2, down 1. Why is it right 2 and not left 2? Good. Inside the parentheses, you do the opposite. Perfect. Okay. My next point on my quadratic parent function would be 1, 1. Go right 2, down 1. Plot the mirror point. And then 2, 4. Right 2, down 1. What's the domain? N range. Okay? All right. Let's look at number 3. F of x equals 1/4 times x plus 4 squared minus 3. Let's list the transformations in order. All right, what does that 1/4 do? Vertical compression. Vertical compression by 1/4, which means that we do what? Multiply what? Multiply y values by 1/4. It compresses, so the y values get smaller. We multiply by 1/4. Okay, what's the next transformation? Left 4. And then down 3. All right, so I have my point 0, 0. A vertical compression, does that change the point? Nope. So then I go left 4, down 3. All right, what about the point 1, 1? What does that y value change to? 1/4, left 4, down 3. So it's just going to be slightly over that line, right? Just barely. All right, how about 2, 4? If I compress that, what does my y value become? My y value would become 1 because I multiply 4 by 1/4. That gives me 1. So I go 2, 1, left 4, down 3. Okay? All right, let's review some things about these. What's the shape of this graph called? Parabola. What is this point called? It's the vertex. And remember that your vertex is either a max or a min. In this case, what's our vertex? Is it a max or a min? Min. Okay. All right, these points. What do we call those? Okay, that's one name. There's 3 more. X-intercepts, good. Solutions. 2 more. No. No. One starts with R and one starts with Z. Zeros. Roots. Guys, you have to know these 4 terms. You've known them for a long time. You've got to get them back into your memory, okay? All right. What do I call this line? Okay, we're going to call it the axis of symmetry. It's a vertical line that goes through your vertex. Okay? Let's talk about concavity. What do you remember about concavity? Okay, it's up or down. Which way are these both? Concave up. Okay? All right. Let's talk about the two forms you're really going to see us deal with in quadratics. Standard form and vertex form. Okay? Hang on just 1 second. Okay, so there's two forms that we're going to pay attention to. Do you remember what standard form of a quadratic is, Reese? Good. Y equals ax squared plus bx plus c. Okay, we can get a lot of good information from this. All right? First is concavity. If a is greater than 0, it's going to be concave which way? Good. If a is less than 0, it's going to be concave down. Okay? The vertex from standard form can be a little complicated, but it's going to make a lot more sense once we try it. So if it doesn't make too much sense now, don't worry about it. Okay? But here's the rule. The vertex is, the x value is negative b over 2a. Okay, so I calculate negative b over 2 times a. And then to get my y value, I'm going to plug this x value back in. Okay, so I'm going to just call it f of negative b over 2a. So I find my x value first. Then I plug it in to find y. Okay? All right, the axis of symmetry. I'm going to abbreviate that as AOS. Okay? The axis of symmetry is the vertical line that goes through what point? The vertex. What's the equation of, how do I start the equation of vertical lines? Okay, so it's going to be x equals, what's the x value of my vertex? Good, so it's just going to be x equals negative b over 2a. In between what? Axis of symmetry. All right, so last thing is to get the y-intercept. What do you think the how am I going to get the y-intercept here? Yeah, it's going to be c. Who said that? Jason, how'd you know? You just knew. Okay. How do we find, Hannah? Okay, how do we know that that's where it crosses the y-axis? What do we plug in to find a y-intercept? 0 for x. And if we plug in 0 for x, doesn't this go away and that go away? So what's all we're left with? C. So our y-intercept is always at 0, c. Okay? That's the one that's really easy to figure out. The vertex is challenging to figure out from this one. Okay? Now, in vertex form, it's going to be flipped. The vertex is easy to figure out. The y-intercept takes a little more work. Vertex form is y equals a times x minus h squared plus k. Y equals a times x minus h squared plus k. Okay, concave up or down works the same way. Okay, nothing changes there. If a is greater than 0, it's concave up. If a is less than 0, it's concave down. Okay? All right. Look at our last two examples that we just did. What are the coordinates of this vertex here? 2, -1. Okay, look at that from here. You see, you change this sign because inside, instead of going left, I go right. Right 2, so it's a positive 2, down 1. 2, -1. Look here, where's our vertex? -4, -3. So I change the inside sign because it goes left 4 and then down 3. Okay? So the way we represent that is that our vertex is h, comma, k. Okay? It's the opposite of what's inside the parentheses. K, the sign doesn't change. So my axis of symmetry, what's that equation going to be? Yeah, but as an equation, x equals what? Nope, nope, nope. Don't make it too hard. H. Because this is the x value. So it just goes through that x value. Okay? Now, the y-intercept doesn't just come naturally. To get the y-intercept, you've got to plug in 0 for x. You're going to have to solve for the y-intercept. Okay? All right, let's work some practice problems. Yeah, I will. There it is, Morgan. Okay? All right, let's try some practice. What form is number 4 in? Vertex form, okay? So let's figure out the easy stuff first. What's the concavity? Up. How do we know that? Because it's a positive a value. It's not a quadratic if it's 0. Okay? What is my vertex going to be? -3, -6. So what's my axis of symmetry going to be? Okay, the axis of symmetry always has an equation. It's a vertical line, so it's an equation of a line. X equals -3. Is my vertex a maximum or a minimum? Yeah, because concave up means that my vertex has to be at the bottom. Okay? All right, how am I going to find my y-intercept? Plug in 0. So 3/2 times 0 plus 3 squared minus 6. 0 plus 3. 3 squared is 9. Okay, 3/2 times 9, that would be 27/2 minus 6, which is 12/2. So what do I get? (15/2). Okay, so do I just write 15/2? How do I write it? Good. Your vertex and your intercepts must always be written as points. Your axis of symmetry must be written as an equation of a line. Okay? All right, let's plot it. -3, -6 is my vertex. 0, 15 halves, which is 0, 7.5 is my y-intercept. I'm going to draw in my axis of symmetry. Let's find the mirror point of my y-intercept. My y-intercept is at 0, 7.5. Where's the mirror point going to be? -6, 7.5. Good. It was 3 units away, so it had to be 3 units away on the other side. Correct. Connect your parabola. Yeah, I'm right. For these graphs, I'm okay with just 3 points. Your vertex, your y-intercept, and the mirror point. All right, what's the domain? Good, and your range? Okay. Let's work one from standard form now. Look at number 5. F of x equals -4x squared, or x squared minus 4x plus 5. No, stop. Okay, is this concave up or down? Up. So is my vertex a maximum or a minimum? And what's the y-intercept? 0, 5. I like to figure out the easy stuff first, then start my computations. Okay, so I need to find my vertex. The x value of my vertex is -b over 2a. So a is 1, b is -4, and c is 5. Okay, so the opposite of b, so the opposite of -4 over 2 times 1. The opposite of -4 is 4 over 2, so my x value is 2. All right, how do I find my y value now? Yeah, plug it in. So now I'm going to find f of 2. 2 squared minus 4 times 2 plus 5. 2 squared is 4. 4 times 2, so minus 8 plus 5. So I'm going to get -4 plus 5, which is 1. So my vertex, what are the coordinates of my vertex? 2, 1. What's the equation of my axis of symmetry? X equals what? 2. All right. So plot my vertex, 2, 1. Y-intercept at 0, 5. Plot your axis of symmetry. Where's your mirror point going to be? 4, 5. Okay, domain. And range? 1 to infinity. Okay, questions? Okay, let's look at 6. Fill in the easy stuff, then start trying to find your vertex. Go ahead and give it a shot. Right, hopefully we were all okay with these three things. Yep. And you should have gotten that the x value for your vertex was negative 3/2. Okay with that? All right, let's find our y value together. Negative 4 times negative 3/2 squared minus 12 times negative 3/2 minus 5. All right, negative 3/2 squared. Positive 9/4. Okay. Negative 4 times 9/4, what does that give us? Cancel your 4s, remember? So it's negative 9. Minus, well, we've got a negative times a negative, so it's really going to turn into positive, right? 12 and 2, those cancel. That becomes 1, that becomes 6. So it's going to be 18 minus 5. So you should have gotten 4. You okay with that? Because this is like 12 over 1. So I can, when it's top and bottom, when you're multiplying, you can reduce. So negative 3/2 comma 4. What's my axis of symmetry then? Not y equals? X equals negative 3/2. All right, so I've got a vertex at negative 3/2, which is negative 1.5, comma 4. My y-intercept is at 0, negative 5. Does that make sense that my y-intercept would be down there? Yeah, because it's supposed to open down. That's a really good check. Kind of pause and think about where your vertex is in relation to your y-intercept. Make sure you're plotting it the right way. Okay? Where's our mirror point going to be? Good. Negative 3, negative 5. All right, domain? Good. And your range? Good. Questions? Feel okay? All right. Number 7, find the minimum or maximum value, then state the domain and range of the following function. So what's it really asking us to do? Find what? Find the minimum or the maximum. What's it asking us to find? Okay, but I'm actually wanting the value. The vertex. It's asking you to find the vertex. All right, so let's start by finding the x value. Negative b over 2a. So I want the opposite of negative 3 over 2 times negative 2. What does that give me? Negative 3/4. We're okay with the x value? All right, let's practice the y value now. I'm going to plug in negative 3/4. So I get negative 2 times negative 3/4 squared minus 3 times negative 3/4 plus 4. Okay, so this is negative 2 times, what's negative 3/4 squared? Good, it's always positive when you square something. Positive 9/16 plus what? 9/4 plus 4. Negative 3 times negative 3 is positive 9, so plus 9/4. Okay, negative 2 times 9/16. Okay, negative 9/8. Plus, how could I rewrite 9/4? 18/8 plus, how many fourths for, or sorry, how many eighths for 4? 32 eighths. Negative 9 plus 18 is 9 eighths plus 32, 41 eighths. All right. Is this going to be a maximum value or a minimum value? Okay, so my maximum is at negative 3/4, comma 41 eighths. Domain, all real numbers, good. Range, almost. It starts at negative infinity to 41 eighths. Good. Okay? All right, we're going to skip 8, but let's look at 9. Take a sec and read through the situation. What's it asking us for? Okay, and if we're asked for the maximum, that means we're asked for the vertex. All right, so my x value in this case is what? R or P? Okay, so P equals negative 2B, or sorry, negative B over 2A. So the opposite of 300 over 2 times negative 15. Negative 300 over negative 30. So what's P? 10. All right, please find R. What'd you get? Okay. All right, so my vertex is at 10, 13,500. But that doesn't answer my questions. Okay, first question. What price will maximize revenue? 10. Price was our x value. So $10 will maximize revenue. Yes, I should say price of. When we solved for the x value of our vertex, it was P. Okay, what is our maximum revenue? Okay? All right. Write the parabola, write the equation of a parabola symmetric about x equals negative 10. There's more than many right answers, but I want you to try and come up with one. I'm going to give you a sec to try it. Symmetric about the line x equals negative 12. So that's basically saying, what's your axis of symmetry? X equals negative 10. It's an equation. What does it tell us if it's going to be symmetric about x equals negative 10? Okay, so the vertex has to have what as its x value? 10. Or sorry, negative 10. Does it matter what your y value is? No, anything could go here. So how would I put that into an equation? Okay, I'd use vertex form. Does it matter what my number in front of my parentheses is? Nope, anything could go here. What has to go in my parentheses, though? X plus 10 squared. And then, could I have anything out here? Yeah. These can be anything you want. All that matters is the inside. So if I asked you for that question on a quiz, you could put negative 17,500 x plus 10 squared plus 0.00007. Like, you can put whatever. Yeah. The only thing I'd be looking for is x plus 10 squared. Okay? Okay, your homework is from your book. All right, there is quite a bit of graphing, so you might want to use graph paper.